Hello, my name is Amir Ali Salami Nazarian, and this is my reverse eng project video. Today I will present my reverse engineering analysis of a TT DC motor, which I have below. The purpose of this assignment was to disassemble a product and understand how it works, what components it contains, and how it is manufactured. The component analyzed in this project is a TT DC motor with an integrated reduction gearbox, which operates typically between 3 and 6 volts. This motor is commonly used in small robots, Arduino projects, and educational robotic kits because it's inexpensive, compact, and easy to integrate into a mechanical system. Reverse engineering this motor helps us understand how electrical energy is converted into mechanical rotation and how gear reduction allows small motors to produce enough torque to drive wheels or other mechanisms. So how the motor works. The TT motor consists of two main systems. You have the DC motor itself and you have the gearbox, right? The DC motor creates a magnetic field which interacts with permanent magnets inside the bearings. As you can see, here's the magnets and the coils in the middle create a magnetic field. How that happens is these two are attached to a power source. The power source brings current through here into this little thing right here, which attaches to this rod. The current then goes in through here into the coils inside, and it alternates. As the current alternates, the magnets interact with the magnetic field produced by the coil, right? Which spins this. When this spins, it is attached to these gears right here, down here, spinning this. These gears now are in charge of spinning these bigger gears. As you can see, the size difference. This size difference makes it so that torque is multiplied or torque is increased while speed is decreased. The bigger gears are attached to the output shaft, which is attached to a wheel or something of that sort that you want to move. Rest is history. So now we have the TT motor uses a variety of materials and manufacturing processes. The motor housing is made of stamped steel to protect the internal components. The gearbox housing and the gears themselves are typically made from ABS or nylon plastic, which are produced using injection molding. Plastic gears are chosen because they are lightweight, inexpensive, and sufficient for low-load applications. Inside the motor, the rotor coil is made from copper wire, while permanent magnets are typically ferrite magnets. Most of these motors are manufactured in large electronic manufacturing hubs such as in Shenzhen, China, where production costs are lower and supply chains are well established. Functional importance. Typically, the TT motor acts as a primary actuator in many small robotic systems. Its main purpose is to convert electrical energy into rotational mechanical energy. Without the motor, the system would not be able to move or perform mechanical work. The gearbox improves the motor's usefulness by reducing speed and increasing torque, which allowing it to drive wheels or mechanical linkages effectively and better. Because of this, the motor plays a crucial role in any system that requires movement, such as a small autonomous robots or robotic car platforms. So the teardown process. To better understand the motor's construction, I disassembled the device step by step. First, I removed the screws holding the gearbox cover in place. Next, the rubber cover. Next, I split open the gearbox, and then I removed each gear separately with the shaft. After that, I took the DC motor and I split it open in half, and now you can see everything in here. This teardown allowed me to clearly observe how electrical and mechanical systems interact to produce motion. In conclusion, the TT DC gear motor is a simple but effective electromechanical device. Through reverse engineering, we can see how the magnetic forces generate motion and how gear reduction improves torque output. Despite its low cost, the motor demonstrates many important engineering principles, including electromagnetism, gear ratios, and efficient mechanical design. Understanding components like this provides valuable insight into how larger robotics and mechanical systems operate. Thank you for watching.